Good morning and welcome to this presentation focused on the collaboration for horizontal infrastructure. My name is Salvatore Macri and I am the solution engineer here in Autodesk focused on infrastructure and based in Italy. Today I'll be the pleasure to share with you some important aspects related to the collaboration in infrastructure project. Here the agenda. We will start from the challenging of the industry. Then we will speak about our core technology, able to relieve the pain, and finally we will go deeper in what we call collaboration for Civil 3D. Let's start. Infrastructure projects are becoming more biggest and complex. There are some common widespread issues that are significantly impacting project timelines, efficiency, and overall the quality of the project. The first is the way that information are shared. Typically, there are many traditional methods, unconnected and based on manual processes. Working on multiple versions is very common and ensure that all the designers have access to the latest version is crucial. A little misalignment can impact heavily on cost and time. The second aspect is data integration. Coordinating within multiple infrastructure disciplines, such as pure transportation aspect, utilities like water or wastewater, civil structure, and more, can be complex and time-consuming. The third one is the change management. Changing are in the nature of all infrastructure projects. Keeping track of all the change and maintaining a clear audit trail of all the exchange and decision can be challenging. In change management, we can also consider the effort needed to onboard new members of the project. What we can do to face this pain? Today we have the solution. We can leverage the power of two main Autodesk technology, one desktop, Civil 3D, and one in the cloud, Autodesk Construction Cloud. Civil 3D is the desktop solution focused on infrastructure design. Civil 3D is a platform that enables BIM process for infrastructure. I encourage you to see the specific presentation delivered by my colleague. The second one is the Autodesk Construction Cloud, called ACC. ACC is the common data environment of Autodesk. With ACC, all the company and people involved in the project, they can collaborate quickly to deliver the project on time and on budget. Let's talk about Autodesk Construction Cloud improve Civil 3D workflow. Collaboration for Civil 3D is based on four main areas. The first one is the document management, meaning Autodesk Docs. The second one is Civil 3D project in the cloud. We are looking how the Civil 3D project and object of Civil 3D are managed in the cloud. The third one is the design collaboration. Interoperability between different companies or different disciplines. Last but not least is the model coordination that gives us the opportunity to perform the clash detection in the cloud. Let's start from the first point, Autodesk Docs. Docs is the foundation of the Autodesk Construction Cloud and is included in the AECO collection. Let's see a bit more the details. Inside Autodesk Docs, the team's member can organize the folder structure with specific permission, access level based on users, role, and company. The folder structure allows to save file and model and to manage the project with versioning, compare tool, markup, issue, and much more. The large model viewer allows to see more than 100 different file formats, maintaining versioning history. Large Point Cloud is one of the file formats supported by the large model viewer. On Autodesk Docs, all the team can implement customer approval workflow to be sure that the final documentation are delivered on time and based on the latest elaboration. Civil View is the latest update of Docs. This new capability is focused on infrastructure project. Now, the members of the project they can explore the model based on the alignment. There are also the different options for labeling the model always based on the alignment position. Leveraging the reviewing processes, in Autodesk Construction Cloud, we also have the capability to collect and see the information organized in different dashboards. There are different cards available to show analytics, for instance for quality, safety, risk, and much more. One important part for working with collaboration for Civil 3D is the Autodesk Desktop Connector. Desktop Connector is the bridge between the desktop solution, like Civil 3D or AutoCAD, and the cloud. Getting started with Desktop Connector is easy. After the installation, you can find the gray icon in your Windows system tray. Click to open and sign in with your Autodesk ID. Autodesk Construction Cloud is unlimited storage and file size, but traditionally, customer doesn't need to work in the same time with all the project. In Desktop Connector, it's possible to select specific project, and you can select up to 80 projects. Once these projects are selected, you will find a specific drive called Autodesk Docs, where you will find the selected project. Then the interaction between desktop and cloud is very easy. It's very similar to the traditional experience based on Windows file system. In File Explorer, as you work within your project, you will have different icons in the status attribute. The status of the attribute can help you to understand what is happening during the processing of your data. Let's talk about security in Desktop Connector. Also here 3 main topics to consider. If necessary, it's possible to activate the offline work mode. This functionality enables users to access and work on their file without the connection, meaning that any modifications are made locally and automatically uploaded as a new version when the user reconnected to the internet. For avoiding data loss, some functions, such as renaming or moving file, are not available offline. Conflict resolution dialog box. Desktop Connector is able to recognize conflict during the elaboration of the file. Conflict may occur when a file is modified in the cloud while a user is working on the same file offline. In such cases, the system prioritizes the change made in the cloud. File deletion. There is a comprehensive file deletion tool. To remove file from all the location feature, provide a thorough cleaning solution by ensuring that when a file is deleted from a connector, it is also removed from the corresponding data source. This feature is essential for maintaining data consistency across all the locations and preventing any confusion that could arise from outdated or unnecessary files. In Desktop Connector, you can also understand what is the situation with the reference file. You can use this utility for any DWG file. The second part that I would like to underline is how Civil 3D projects are managed in the cloud. There are 2 ways to open file from Autodesk Construction Cloud. You can start from the tab in Civil 3D, then click on Autodesk Project, and then you can choose in your account or app name and project. Then you can navigate in the folder location, and in the number 5 you have the list of the file contained in the folder in ACC. If you prefer the traditional file, you can work like open file from Civil 3D, then click on the icon and navigate in your account or app by clicking in the Autodesk Docs. When you click to open a file, automatically you will receive a notification regarding what Autodesk Desktop Connector is doing. Desktop Connector only downloads the file needed, like the XREF data reference. After that you open your file in Civil 3D, any change that you do in your XREF file, then you will receive a specific notification, like in the image that you can see now. The same thing is regarding the data shortcuts. For non-Civil 3D users, the data shortcut is the tool inside Civil 3D that the project member can use to share Civil 3D objects among all the teams. The third part is the design collaboration. Design collaboration is the tool that allows the project member to track the progression through a timeline. Design collaboration increases efficiency, is direct and smart for understanding the progression of the project and for creating the federated model in all the disciplines. In design collaboration, it is also possible to activate notification of change. Design collaboration dramatically improves multi-theme project teams' ability to meet the demand of the modern project lifecycle. The last part is the model coordination, adding clash detection and coordination issue. Here you can see how the project member can switch from design collaboration to model coordination. Model coordination model browser add two more crucial features for the team. Combine the different model of the entire project, this is what typically is called federated model, and also enable filter by element or categories or more. In model coordination, we can also detect clashes. We know how it's important to anticipate coordination issues and constructability problems. When the 3D file like Revit, TWG, NWC or EFC models are added in the coordinator space, Model Coordination Clash Service automatically detects a clash between the objects in those models. Then the project member can then review the detected clash and either mark clashes as not an issue or create an issue for further investigation. For supporting the team member to share information inside model coordination, it is also possible to save specific view focus on specific part of the project. In the last part of the presentation, I would like to share with you a practical example. This is a typical workflow in infrastructure project where are involved three different roles: the surveyor, the road designer, and the drafter. Let me explain a bit the process. The workflow starts with the surveyor that shares the first version of the survey with the road designers. The road designers start to use the survey for creating the alignment, but a portion of the survey is not enough big to complete the alignment. At this point, the road designer asks for an update to the survey. Surveyor adds more data and then share again the update with the road designer. Then, road designer can complete the alignment design. After the align and profile are properly designed from the road designer, one more role is added in the workflow, the drafter. The drafter will use the survey data and the alignment for create deliverables, in particular the civil 3D corridor and the cross-section. To understand which role is doing what, I invite you to see the top right corner of the slide, where you will find the indication of the role. Let's start. In the first video, we are looking how the surveyor initiates the project in the cloud. The first operation is to save the project via Docs application directly by Civil 3D. Immediately, desktop connectors start to synchronize from local to cloud. Then the surveyor creates a Civil 3D surface applying the different style object. The crucial step is the usage of the data shortcuts in the cloud. The data shortcuts is the feature that Civil 3D uses to share Civil 3D objects like surface, alignment, profile, and much more. In the last step of the video, we can also see how the file is locked until that the Civil 3D session is not closed. To ensure the cloud collaboration, also the road designer starting with saving the drawing in the cloud via Autodesk Docs. In this step, the road designers start to use the topo surface just shared by the surveyor via data shortcut in the cloud. How you can see in the video, the surface is too small. It doesn't cover the entire extension of the alignment. Road designer can also check the data via large model viewer. And to notify that is needed an update, he creates an issue. By receiving a notification via mail, the surveyor can explore the update request. We can imagine that at this point the surveyor goes outside to integrate the survey and ultimately upgrade the topo extension. This last update is immediately updated via data shortcut in the cloud. Road Designer opening the work in progress file and can immediately understand that now the survey has the proper dimension. Road Designer can also compare the two different versions to understand which changes are made by the surveyor, and finally can also close the issue. This is the step where the road designer studies the alignment. The road designers use the Civil 3D capability for creating a proper alignment and to profile. In the video you will see all the steps needed for creating and extracting the profile view. At this point you are looking at the design of the alignment just on plan. When the plan is defined, we can also create the profile of the surface, and ultimately we can define the design profile of the road. At the end of this Civil 3D manipulation, the road designer shares via data shortcut in the cloud, alignment and profile. The working process drawing is also available inside the large model viewer of Autodesk Docs. At this point of the workflow, we have all the main elements for creating corridor and deliverables. For this last step, we can imagine that a new role, like a drafter, jumps in the process. Based on the previous object, like surface, alignment and profile, using the same data shortcuts, the drafter starts to create a Civil 3D corridor, and then the cross-section. The video contains all the steps, feel free to look it until the end. This is the workflow that we are following. 3 different roles: surveyor, road designer and drafter. Now, for any reason, all of them can change something. But due to the collaboration in place based on Autodesk Docs and data shortcut on Civil 3D, for any single modification, all the other roles will receive a notification. Let's see. In the left side there is a road designer. In the right side there is the drafter. Consider please that potentially they are working in different locations and also in different companies, but in the same project. For any reason, according with the scope of the project, the road designers start to change the original configuration of the alignment and of the profile. The change has an impact on all the drawings related to this alignment. After the changing, the drafter will receive the notification that one element is changed. Look please on the right side. Desktop connector send a notification and then the drafter can decide to update or not all the elements. No file is changed. This technology radically changed the way of work. There are two more advantages of collaboration for Civil 3D. Design collaboration and model coordination. With design collaboration, not only is possible to share the package of the file, looking the difference between one version to another, but also allow the capability to track all the changes in a sort of timeline. Design collaboration is also the tool that company and design they can use for aggregate model. In our example, we saw the workflow between surveyor, road designer and drafter. But as mentioned early in the presentation, in the infrastructure project there are involved multiple roles and company. In this last part we are looking for instance gravity network. As you can imagine, all the underground utilities are potentially source of intersection. In model coordination we can say specific view based on the exploration of the model and, if needed, opening an issue based on the class detection. I would like to thank you for attention. Feel free to contact me for any question or clarification. Thank you.